This nice fellow to my left-hand side is Johan. I'm Vasco Veloso. You probably already figured it out with the photos on the big screen up here. We work for ING, a Dutch bank with, what did they say a few years ago? It's not a bank, it's
IT company with a banking license.
Exactly. Therefore, we are both active in backend development, mostly Java and JVM based, which means that there is a very high focus on everything related to backend application development, etc. Before we get to the topic of this conversation, I would like to ask you two things. The very first thing, since now it's the first session after lunch, is who is asleep right now? Thank you very much. I will try my best to not disturb everybody who put their hands up. And the second question is, who has heard already today people talking about efficient software? Lovely, you'll hear it again. Thank you very much for coming. Our conversation is about, building efficient software, specifically with some advice that Johan is going to give and show. It is a show and tell session. But first, I would like to get started with a wall of text. So, what do we mean when we talk about green IT? Specifically, there is a very big definition out there. But let me just, get it down to what matters. Green IT is about developing software which uses as little resources as possible. Now, it just so happens that 50 years ago, this was an absolute necessity. Today, it's more of a luxury. How did that happen? Quite simple. Never mind, don't even try to read the numbers on this chart. They're too small. But the whole point is that we have Moore's law, on the one hand, to thank for it, because every year that goes by, computational power increases. And therefore, every year you get the ability to do things which are more complicated than they were the year before. If we add to it the fact that computational cost and storage cost has gone down dramatically in the past few decades, then we have an explosive combination. And the combination means that whereas 50 years ago, if for some reason whatever algorithm, whatever code you wanted to write didn't fit in your memory, or it was taking too long to compute, you had only two choices. Either you would give up, or you would have to devote time and effort to optimize the thing so that it would run accordingly to the computational power of that time. Looking at these graphs, there came a time where it became cheaper and time effective to just throw hardware at the problem. Oh, it's running out of memory. Yeah, sure. Just a couple more modules there. Problem solved. Is it too slow? Fine, we buy the newest processor. It's faster. Problem solved. The same thing happens nowadays when people provision resources in the cloud. It's so easy, right? We're running out of memory. 2 clicks in the user interface. Bam, you have more memory. Problem solved. Your credit card may not agree, but your computational problem is solved. An example about this. Who was still paying attention this morning during the keynote when our nicest friend Molly said that the Zoom's landing page is 5 times bigger than Doom was back then? I mean, who has even played Doom in their original version? I want to see some hands because, yeah, thank you. And that's the interesting part, right? I mean, when Doom came out, it would fit inside a standard floppy disk at the time, a 3.5 inch. If for the new people in the room, it was something that looked a lot like the save button on software. Okay. But nowadays, Doom, and I'm not talking about the new version which just came out or is about to come out, the previous one, it exploded to a whopping 55 gigabytes. And that's just because we can. Now, I'm not saying that the nice folks who wrote the software are not using resources efficiently, but we can. And this is explosive growth. Just to put it into perspective and to bring it back to the work most of us are doing on a day-to-day basis, nowadays the default setting for the heap size on a program running on the Java runtime is 25% of available memory. So it does not really matter what it is that your program does, but if you do not change it, the JVM will allow itself to occupy 25% of your memory. It can be an awful amount, and this is all about expectations, right? The defaults are based on what people have looked at usage and they said, okay, this sounds reasonable, but it is actually a lot, and it is not necessarily efficient.
Even if you don't need it, you get all the 25% as a gift, so you can start using it, but yeah, maybe there's no need to, and you can use your resources much more efficiently.
Precisely. Now, and why is that a problem? Well, let's just put it this way. If we start looking at estimates, like everything that we use, everything that we do, everything that we build generates emissions. CO2 equivalents or carbon equivalents, how you want to name them. And there are different estimates to the footprint of today's IT and ICT landscape. And of course, estimates and studies are a bit like a belly button. Everybody has got one and they're all different. Which is why we have some folks saying, well, maybe ICT today is between 2 and 3%, then other folks saying, no, it's a bit higher, it's between 2 and 4. But the point is that these numbers are estimates for the current level of emissions of our industry, of the stuff we are doing right now. And how would it look like in the future, you may ask? Again, different estimates. On the one hand, they say that by 2030, 23% of global emissions may be due to ICT. Others say 14%. If we go to the most conservative estimate, then we would be looking in 2040 at ICT being responsible for the same relative amount of emissions as the entire transportation industry today. Because today, the transportation industry, trucks, planes, cargo ships, they are responsible for approximately 14% of emissions. In 15 years from now, that could be us. So we keep that in mind, because next time you see a truck go by with a container, that might be the container you deployed yesterday.
And these are old numbers as well.
Yes, and these are old numbers.
2018.
And these are old numbers, which means, thank you for pointing that out, Jonathan, Johan. I sometimes call him Jonathan for some weird reason. These numbers, they do not take into account modern stuff such as crypto, Bitcoin, or even, God forbid, AI. Just the other week, I was reading that AI, training and running models, is now, according to those estimates, using as much or even more energy than crypto. And that means a lot. What can we do about it? Well, we can go back to the basics and start caring about the way how we develop software. We have 3 big areas where we can do things. right? We can change the way how we go about our networking capabilities. We can concern ourselves with scalability and, of course, software efficiency, the good old optimization or the good old thinking before writing the code. When it comes to networking, there are easy gains. And some of this stuff is already being done every day automatically, for example, compressing payloads. It's there. We can also make a conscious choice to choose more efficient transport protocols. So if you are using XML just because you like it, then probably you could take a pill and change to JSON, or even go gRPC if you don't need to understand what's going on the wire. A suggestion. We can also do something which is very simple, like when you have an endpoint which is supplying data. Instead of defaulting to supplying the whole bunch of information, let your caller tell you what they want, what they need. When it comes to scalability, we also have a number of options. We can choose to run stateless applications, which allows us to scale up and down the application as necessary, flipping the switch on and off. We can use horizontal scaling capabilities of our platforms. And this not only reduces the CO2 footprint, but it also helps with the finance department's budget. For software, well, we can use asynchronous calls. And why is that there at the top of the list? The reason is that even though nowadays with the new JVM versions and since a few years back with Kotlin and other frameworks, we don't need to rely as much on platform threads. They are still there, and they are also often used to handle I/O. But the reason is that if the CPU is not blocked, then of course it is free to do something else. When it comes to recent developments on software, on the way to build software, on the way to write software, we also have new techniques such as the ones that Johan will show in a moment, which means whenever you can also not use bytecode, not use interpret code, but instead run it directly on machine language. And if you can, looking at your platform's energy consumption, let's just say that you have a batch job that runs at peak hours, probably around dinner time, to calculate, I don't know, the sunset time, whatever. If you can run that at a moment where your electricity is being generated mostly from renewable sources, then your impact is lower. It does not mean that you need necessarily to optimize that job. It's probably already optimized to the biggest extent, but you can run it at a different time.
Yes.
And now, Johan will step
We'll break
in
stuff, right? That's the
and go native.
Yes. So in my daily life, I'm 80% engineer in a team and 20% developer advocate, telling people about engineering culture and helping them get better at their craft. And well, this is one of those things where I think in a team you can actually win a lot depending on what type of application you use. Vasco already pointed out a little bit that you have to have certain applications. If you're already CPU bound, it won't benefit you, but for most applications that's not the case. And most of the things we saw with native builds were hello worlds and then quickly testing them, and that's all interesting and nice, but I don't think anyone here is running hello world in production. So we figured, let's make a REST endpoint, which is quite common, and have a database in between, have some conversations in between, so we're actually converting the object from the database, the entity, towards a Java record, and then giving that back. And to prevent calling the same URL all the time, I did something very sneaky and added a random feature, so you could actually just call them with a maximum number, and then it would give you those fields back. So you could somewhat simulate what's happening in production in real time, because no one calls the same data all the time. So we have endpoints, we have 3 types of applications. One is built in Spring, one is built in Quarkus, and one is built in Micronauts. And well, Helidon is still on the horizon for us, but that's also an interesting framework to check out. So all in all, you can see here the endpoints. I'm just calling quite a simple entity, getting data back and returning the records. And I have an enumeration for the status, which, well, it's a task application, so we kept it quite simple. So to run this, we typically would, at this moment, run it as a JVM application, in which case you get awesome tooling like Visual VM. Anyone here has heard of Visual VM and used it? Not too many people, so I do hope I will make you a bit enthusiastic to check it out for running locally and see what the performance does of your application. So let me actually, well, I'm in the Quarkus directory, so why not? If all went well, I did actually already jar. Too bad. So this one doesn't work. Let me then build the native application itself. So what this does is that instead of running things in a JVM, it will compile the jar, but then afterwards we'll also start checking out which elements are used or not used. So I will try to make it a bit bigger, because ignore all the little details, because that's the preparation of the build. You can see here it will start building now. So it's using GraalVM to build natively, and typically this application will build in like a couple of seconds, but because it's Graal, it has to check out which of your methods are used, which of your functions are used, and throw away all the other stuff, because those frameworks, Spring alone, if you make a basic Spring application, it's huge. It's over 100 megabytes. And a lot of those things you don't actually need. We have a simple task application. I don't need all the extra stuff that you would need in an enterprise application. And you do get those for free if you deploy them as a jar. So what Graal does is also a security layer on top, that it only creates the code that you're actually using. And beforehand, Quarkus was quite good at building native applications, and the Spring team also jumped ship at that point, building Spring Native, which was still quite a lot of work to actually configure. But with modern Spring 5 and beyond, you do get a lot of those references already supplied by the Spring team. So Quarkus does it out of the box, and as you can see, I've just built the application natively, and it took me 1 minute, which, well, some people complain that GraalVM is slow, but overall it's not bad. It does have to do a lot more than a normal build of Java. But now I have an application. So as you can see here, the resulting binary is 82 megabytes, but that's not a jar file. It includes all of the Java, the JVM parts that typically you would have someone install in an environment, but they are now available within this binary, so you no longer need to install Java. This will also make your Docker containers a lot smaller, for example, which again helps with green IT. So to actually run this application, runner, yes. I sometimes have to run it twice, but I think it started up quite rapidly now. Yes. We have virus scanners. I work for a bank, and sometimes it interferes with my quick run. But as you could see here in all white, the application started up in 0.035 seconds. I don't even have to wait. And the interesting part in this for a team is if you have test and acceptance environments or even production, there are moments during the day and during the week that your application is hardly used. And you can actually scale down at that point. And if you need it back up, then it's so fast to actually start again. So a user won't notice these amount of seconds. If it takes 5 seconds, sure, a user will notice. But in this case, it's near instant. To show you, and this is Visual VM, it's an open source tool that you can download and install on your PC. Normally, you would need a JVM for this. But there's a nice feature in the build tools, both in Quarkus and within Spring, to enable you to monitor. So it doesn't offer you all the options that you would have in a normal jar that you're running, but it does give you some insights on what the application is doing. So the application started, it's not using any CPU at the moment, and as you can see, the current memory usage is 70 megabytes for just the REST endpoint running. Try to do that with a running JVM. I haven't done anything yet, though. So just to be sure that it is working, and the weather here is much better than in my hometown, as you can see. It will rain tomorrow as well. Let me see, this is Quarkus, so it should be on 1. There you go. So what we have here is, we just have some titles and who is working on it, what's the status. Vasco, you have to do some work, as you can see. These are book titles, I had to find some random data. You can already see at this point, I just did some F5s and nothing happens. So there are better ways to actually performance test this. And one of the tools that we like to use is called Hey, which I will start up now. If I can actually find a README, there you go. Well, we have Quarkus here, which is running on 8081, so I use different ports to put those applications next to each other and also see how the application behaves, because every framework has their own strengths and weaknesses, just like your own code that you're implementing. So what this does, and I have to run it twice, just in case, because sometimes there is a warm-up needed. You can already see that it's performing quite well at this part. So let me run it a second time. This application calls 250,000 times, yes, instead of 2.5 million, and it will actually give you some insight on how the application performs. So if you do consider using native implementations on your application, well, with Quarkus it's very easy to switch, with Spring also by extending it with a native prompt, which I will show you shortly. Then you can compare both applications with one another to see how they perform. Typically people tell you that JVM needs to start up slowly and at a certain point will start performing better. What I've seen overall is that if you use the ML inferred optimization or PGO itself, which is a profile guided optimization, they come really close. And if you're not focused on throughput completely, because your application might have to do a lot more things than just quickly answer and handle a lot of requests, not all applications require this, then it might even be that with the default settings, your application is already performing much better in resource usage. And the interesting part is, I have here 2 small spikes, and that's the CPU part. If I'm running this on a JVM, it will spike all the way up to 60–80%. Because the JVM has to start thinking about, okay, what's going on, all those 250,000 requests, how can I optimize this in the meantime, has to do some garbage collection, etc. You can also see the memory usage, and it actually went down. So the resource usage already was insanely low for a Java application. I mean, if I run a normal Java application, I'm not using 25 megabytes of memory. We just showed that 25% is taken. And typically, we don't have 100 megabytes on our laptops anymore. We did in the Doom time, although even then I think we had much less.
Well, I don't remember the numbers exactly, but I think you could see these heap sizes around Java 1 or 1.1, give or take.
That's almost before my time. But
yeah.
Although I'm over 30. But the nice thing is that you can see here that it's quite predictable and stable. So if you're running this within a container, you can scale up more easily because you do know if the application is called this way, I will need, for example, 2 servers or 4 servers. Well, with a typical JVM application, well, it's all available, it's reasonably cheap. We just put the servers there and we start running them, which could mean that you're actually running a server that only maybe uses 2, 3, 4% CPU, which is a waste. We could do a lot more with that hardware. So I will now close down the application of Quarkus and see if I can actually get the JVM version of my big friend Spring working. I'm not going to rebuild them again. I already built them earlier today to check if they're working. If you do want to see me building extra stuff like the profile guided optimization, I can do that because it does take some time, as you've noticed. Let's see if I can actually get this one to start up. The downside of all these frameworks is that they have their own names in the applications. This one is working, nice. So as you can see here at the bottom, the JVM version of Spring, it's a simple application. But still, it starts up in 2.3 seconds. That's nowhere near those 0.035 seconds. So if you have a more complex application, it might take 5 seconds, 10 seconds, and then you have a user waiting if you need to scale up. So what happens if I open that in Visual VM? Well, I get a lot more options, as you can see, because this is the full JVM. But I'm also already using 86 megabytes, well, not doing anything at all at the moment. So going back to the browser, and Spring is running on 8.0, so there you go. Again, simple application, and it just gives you some data back. But this is nothing fancy going on, although you can see a big bump in the memory already, even though I just did a few F5s on getting some simple data back. So running this same Hey script on the JVM, you can see the big spikes already. And as I mentioned earlier with the native build of Quarkus, and I will show you the native build of Spring as well, it's a lot more stable. You don't get those big spikes. You can also see the memory spiking up insanely high because the memory is available and the JVM is like, I can use it, why shouldn't I? So this is the main difference between native builds and JVM builds. What I'm typically doing if I'm building a native application is that I will test and build locally using the JVM. And then once I want to go to an environment, like for example, test or acceptance, I will start making the native images because, well, it does take a little bit more time. And if I need to change things, it's much faster with Java itself, because we all know Java performs quite great, especially if you use one of the latest Java versions. So as I've already built the native application, and again, this could be faster. I guess this is the virus scanner again. 0.1 seconds. So Quarkus was a little bit faster starting up, but still a user won't notice 0.1 seconds in startup. It's there already. So picking up the application here, and you could see before that the application had a lot more information available. That's simply because the JVM allows that. But here too, I'm using a lot less memory at this point. So let me rerun the tests. And I should have run the JVM test twice for the warm-up, but yeah. As you can see here, it is still quite high in CPU usage, but it's more solid because it knows what to expect. It's built that way, being ahead of time compared to the JVM that has to think about what does the user want here, what does the application have to do. You can see that Spring actually is using quite a bit of memory, but again, it's reasonably predictable. There's no spikes all over the place. So if you do have an application that's constantly touching boundaries in your container, then it might become interesting to actually look at either native builds or scale up with more machines, of course. So another framework that we've tried out is Micronaut. And Micronaut's promise is that, well, the name is in micro. They do try to make the resource usage more efficient. Let me kill the application. I did make it a bit protected, so if I'm running one, I can't run another one because the database will say, I have a lock. So let me start up Micronaut as well. As you could see, it was also quite fast. I do hope I have the AMX export enabled. And it should also show up in here. That's native still. No. Doesn't look like I enabled it. We have a wonderful application called Activity Monitor that also gives us some insights in memory usage. It's native demo, I think. There you go, native demo Micronaut. And you can see here it's only using 40 megabytes just to have this, well, same REST application running. So if you're really memory constrained, it might also be interesting to start looking at Micronauts. For ING itself, we do have some Quarkus applications, but most of our applications are built in the Spring framework. So for us internally, it's more interesting to actually run this on Spring. But I've already seen that Quarkus does a lot better because, well, Spring has had their whole backlog of all those, I think over 15, maybe 20 years of being the alternative, and Quarkus was built from the ground up with containers in mind and with native in mind. Let me also run the test here, and unfortunately I can't show you the Visual VM live demo. If you haven't heard of Visual VM, I really urge you to check it out because it's, even running locally, you want to do some short line performance testing, it's really insightful to see what's happening with threads. You can make heap dumps. You can also make heap dumps of native images and open those up in, for example, the memory analyzer tool or in IntelliJ itself to look what's going on. So I've run a lot of tests now, and the application now uses 40 megabytes of memory because it had to do all that work along the line. Looking at practical ways of implementing this, I've built an open source application for people who stream games and do speedrunning to run along with them and actually measure what's going on and with information that they can display on stream for them. The main information that I got back from them is this shouldn't use a lot of CPU, this shouldn't use a lot of memory because it will impact my stream, it will impact my game. And I've had people actually play for 12 hours on end trying to beat a speedrun record of 11 hours. And the application ran fully stable in memory and CPU usage, fully predictable. And that's one of the main benefits I foresee with native. So that also applies to our applications running within the company. So let me see. Should I do the Profile Guided Optimization Guild guide?
I think we still have a few minutes.
I think we have some. So let me see if I can actually do that for the... So what this does is you typically get the... I built a Quarkus version earlier. So what happens when it starts building? It will infer at the start... in this case, the PGO is actually user-provided, so it already picked it up. In some cases, it will also, if you don't supply any profile, it will use machine learning, and, well, in my experience, that does quite well. It's like maybe over 90% of what you would get with a true profile. So what happens in a profile is that I run the application normally, start doing what I'm normally doing. So you could run this for a day in production, for example. You will get a profile file that collects how are people using the application. And then the GraalVM native compiler will actually use that to improve the builds that you can then deploy and get, well, the almost ultimate performance out of your machine.
In a way, we can compare that with Hotspot, can't we, Johan?
Yes. And these things are not new. These profiles have been around in C as well. So let me actually see. I'm not running anything anymore, I hope. No, everything is done. Cool. So now I have to rebuild. Do I still have the...
While Johan rebuilds, the comment I made about comparing it to Hotspot is basically, since we are building a native image, that means that any optimizations that need to be done with regards to code layout or even code optimization techniques that the compiler uses, well, if we don't specify a profile or if we just allow an automatic profile, then those optimizations are going to be generic. As we all know, the Java runtime environment, while the application is running on bytecode, will have Hotspot or similar technologies running which analyze the application's behavior and apply different levels of optimization in order to get the most out of it. The big advantage is that, like Johan said, if you already have a battery of tests that simulate your typical usage of the application, then you can, when you build it already, you can have it optimized for that specific pattern. And that can be important, but again, depending on what you are aiming for.
Alina doesn't notice, but thank you, Alina. So we have to wait for the build to run. So basically what it does at that point, it will include all the information to create this profile for you while running it. So what you would typically do is like run it for a day or a week on production, so you have a real life situation on what's going on. And this is typically quite fast. The one thing I did notice with building with both Micronaut, Quarkus, and Spring is that Spring does seem to use a little bit more memory within GraalVM. You do occasionally also find websites and blogs like 3-4 years ago complaining that, oh my god, GraalVM uses so much memory. Back then it was like 6 to 8 gigabytes. You do see them improving each version that they have. So I'm running this with the latest stable version, the 24 version of Java as well, so I get all the nice goodies that the new JVMs give you. And because you don't need to tell people to install the JDK, you do get all those things for free. That's also why I use GraalVM to share my program with the streamers, because I don't want to tell them, hey, you need this specific version of Java to install, download it there, and take all these steps. They are not engineers. And if you do this within a container, the same thing. You only need your base Linux image to run it in, and your container will be so much smaller, because typically a JVM nowadays is like, what, 400, 500 megabytes as well? There's so much things in there, and you don't use them at all.
I suppose so, yes. It surely takes up a couple of 100 megabytes. Even when people optimize and remove some modules they don't use, it still uses up a lot of space.
Yes, and I would like to point out, if you do the profile guided build, it doesn't use a lot of memory, so don't do that too often. It should be almost done now. So again, it has to build all the extra information gathering within the application to create a profile for you. So once it's done, I will run another hey test on top of it, acting like a true live user, which will create a new file, and that file can then be used to create a new build that's fully optimized for your environment. For a while, you had to do this all the time on Macs. Nowadays, I think after GraalVM 23 and beyond, the machine learning inferred solution is available by default, and that works quite well. Let me see if I could actually, that's the one. It starts up really fast, so that's always nice. And this is Spring, so in case you're wondering why I'm using 127001 here, I did have a performance issue earlier with Spring, like a year ago when we first built this. And it turned out this was created by using an older version of Tomcat that caused performance issues. So we didn't see a lot of improvements over running natively on this MacBook, which is quite modern, and my 10-year-old PC. So we thought it might have been DNS, but it wasn't. Hence the IP address instead of localhost.
Yes, it was the only exception so far to the rule that says when you have a networking problem, it's always DNS. In this case, it wasn't. So that is an outlier.
Does this work, or will IntelliJ be angry at me if I do this? No, it doesn't. So this is the generated profile at this point, and it creates all the actions that I've just did. So I call it 500,000 times to check at least out, like, this is like how the application is used in real life. And to use this application at that point, you would use this default iProf, but you can give it another name as well if you have specific situations, to build that super optimized binary for you, which of course you would typically do once in a while, once you keep the same libraries and software and only add some small functionality. If you make big changes, you would have to do this again. It will take a bit longer to build the fully profiled application, so I will give the PowerPoint back to Vasco to talk about measurements, because this was a lot of measurement for you as well. If you want to look at how does native help me, or does it help me, you should start measuring, and every application is different, so
Precisely. I mean, I don't know. I hope you did not feel bored by these few minutes. At least the people who earlier said they were asleep probably stayed asleep. But this is the truth, right? If we are going to try to find out if a specific technique works for our application, then there is only one way to know. You measure, and then you measure, and you measure again, and you keep on measuring. It can be a little bit complicated then to estimate, okay, so I am looking at resource usage, but then if I am asked to run reporting on carbon emissions, then how do I do that in a way that makes sense? The principle is the same whether you are measuring for CPU or for memory, or whether you are measuring for carbon emissions. There is an expression from a measuring method being worked upon by the Green Software Foundation, which is the software carbon intensity. Now, this is not complicated, but the thing I want to point out is the last bit of the expression, where it says per R. That's per unit of work. Because if we optimize our application in such a way that the same container or the same deployable unit, let's call it that way, which yesterday was capable of running 1,000 requests per second, and we tweak it, we build it with native, we go and look at the code, and we make some changes, and now it can run 10,000 requests per second. It is extremely efficient in comparison by one order of magnitude, even if it still uses the same amount of resources. So yesterday it used 100 megabytes, today it uses 100 megabytes. What's the difference? Well, it can run 10 times more requests. And I believe that this is a very important point. Now, you don't need to do these calculations by hand. There are quite a few dashboards, quite a few ways of measuring out there. Some of them are available in the public cloud. Others, well, we at ING in our own internal private cloud, we have something we have called the ING Sustainability Dashboard, which is used exactly to do this. Those are cloud-specific solutions, also with Google, Microsoft, and AWS. And then you have also open source and well, cloud-agnostic solutions, some of them better than others. But the idea is always the same. You measure, you establish a baseline, you get your data, and from that moment on you start optimizing and you start comparing with your baseline. Just don't attempt to optimize stuff which does not necessarily need to be optimized. Now, that being said, I hope that we have given you some ideas of what you can do, not only to optimize your application, to make it use less resources. I hope that we have at least given you something to think about when it comes to emissions. Johan, the source code is available.
The source code of the demos that I did are available online, so you can just pick them up and run them on your own machine or locally, or share them with other people, like, hey, you can check this out as well. We have our socials on, and I think we have a couple of minutes for questions left, so I'm curious, is there any question in the room?
Yes, there is one question here in the front row. Okay, so the question was regarding to the suggestion of compressing data which is transmitted over the network. Is it possible that compression is more expensive than the data that's being transmitted? The answer is everything is possible. It really depends on the amount of data that you are transmitting. So, for example, if we look at today's websites, if they need to transmit, I don't know, 20 megabytes of data just to load the front page, uncompressed. And if you can compress that into 2, for example, then in that case, probably the computing cost compensates for the emissions which would be generated when transmitting that data. But then again, it's a matter of measuring height. So you have your traffic, you have your CPU usage, your memory usage, you have your networking statistics, you establish the baseline, and then you flip your usage, and you see if the flip for that specific use case is beneficial. The rule of thumb is that in vast majority of cases, you do have a positive impact.
This is why measurement is important, because any application you build, we're not building boilerplate applications to bring to production. There's always some extra productivity included from your local business department. So if you do change things, really measure them. Measurement is so important. That's also why we use visual VM, for example, to show what's happening. So in some cases, doing it beforehand and compressing might be benefiting you, but the application of the team next to you, it might have benefited them at all. So that's why you always should measure if the outcome benefits you.
The calculation, yeah. Yeah. Okay, so the question was, why is the unit of work definition in that expression a constant? That's because you need to define what your unit of work is. So let's say that you have, for example, an API serving HTTP requests. If you define that your unit of work is serving one HTTP request, then that's what it means. And so what you do is you count the number of HTTP requests served during the measurement period, and you divide by them. So basically, you need to come up with your own definition of unit of work, which is representative of whatever it is that your service is doing. This is the most difficult part of measurement, which is to choose the unit of work.
It seems that it doesn't get much to the result. And the main part is the energy times.
It allows you to compare runs. So if you define what is your unit of work, like the example I said, so if your application is running today using a set of resources, and it runs tomorrow using exactly the same set of resources, but it is able to process more units of work, then your emissions per unit of work have gone down. So that's the logic. I saw another question around here. Yes?
Well, thank you, Alina. It does work. As long as if you compile the code in native, it has to be reachable. That's the only thing. But nowadays, all those jars, I didn't actually let me quickly, because we have 1 minute left.
Let me just add, for the benefit of those who are streaming, the question was, does OpenTelemetry and other technologies also work with native? And the answer was a very strong yes.
Yes, because all those libraries, and this is a community maintains GitHub repo, all those libraries have given Graal and other native builders the full reachability. So once compiling native, it knows which functions are available. And I think OpenTelemetry is also part of this. There you go. So, and you can use this overview as well to see what is available. And if it's not available, you can create it by yourself. There's also instructions available on this website, and then submit it and help out not just the Graal VM team, but also all the other people using native builds. So.
Yeah. We may have sufficient time for one more question, if there is any. I give it 3, 2. One more question for the gentleman in the front. Sorry, I didn't quite catch that.
You have this dashboard for carbon emissions is for regulatory requirements.
The question is whether the dashboarding is to fulfill regulatory requirements. Well, the organization is indeed required to report in terms of carbon emissions. However, I should also point out that the reduction in carbon emissions also means a reduction in resources. So it does benefit your regulatory requirements, but it also makes sure that you are using less resources, you are spending less, you are being more efficient.
Yes. As we are over time, if you have any other questions, feel free to reach out to us. You can use our socials, ask at the conference, we'll be around. And well, enjoy the rest of the conference.
Thank you.